Question is asking when we mix this ribofuranose ring in water, in acetone in the presence of acid, what happens? So first thing first is that we should just see what would happen if we have an alcohol, let's say something like this, and a bit of acetone, or an excessive amount of acetone. Well, since it's an acid, we'll be able to protonate it. So that's step one. And what we get is, that means this can attack here and here. That leads to, after the proton transfers, that leads to so basically an alcohol group forms, and then this extra proton goes there and we form a water. Step two, what can we do? Can remove it that way. That forms this sp2 style intermediate. Looks a bit like a carbonyl. And then this one can go ahead and attack. And then what you get once you remove your extra proton is something like this. But for this to happen, for two reactions to happen, there is an important condition, that the alcohol group should be on the same face. So in this case, these two can have an acetylation product, which is basically this. But it gets a bit harder once we go slightly ahead. Now, the next important thing to remember for this question, and I think this question is not really worth the number of marks, is worth much more than the marks she gives for it, but I guess that's not because it's a bit of a hard question, and you can find some information on it in the 8th of March lecture in the podcast, not much in the notes, is that this is a beta-D ribofuranose, and this one is pointing towards us. We can also do an alpha-D furanose, which is basically everything else the same, except this one. So instead of pointing towards us, this one points away from us. So what are possible products? Here, if it combines with the acetone, what we can get is because, sorry, that's not how you draw that. Can get that. This one and these ones may also react with the acetone, but they would react to form a single one. So you can also put that potentially you might get something like that. As well as this might be a whole, but I think this one would be much more because this one is quite likely to just be hydrolyzed by water, so it would just be protonated and water will attack and get rid of it again. Or this one just pushes it back. So primarily for this one you would get this. Now what about this one? This is the alpha-D ribofuranose. And here you can have, if you're having the complete acylation product, you can either have, and that is not how you should draw it, either that, and again you can acetylate these ones like this, but that's not as important for a 6-mark question, I think. Or you can have it between these two, because these two are on the same phase. The important thing is they should be on the same phase for the double reaction. Sorry. Or that. But that's not the whole story now. These are both furanose forms, and most of the rings of a sugar solution are in the pyranose version. So let's go ahead with the pyranose version and try and draw them and see what products we'd get. So this is the ribofuranose. If we break this bond up, which is basically we will get some form of the straight chain again. There isn't a lot of the straight chain in, so you don't need to really account for that in... This is like the carbono. We need to bring this one here so that it can attack. So if this is pointing towards us, this is in the plane of the paper. If we rotate this to bring this within, to bring this flat and this flat as well, what we'd get is something like... Now this bond can attack either at the top or at the bottom. So what you would get is the alpha and beta forms of this. So what you would get is, sorry, there's one carbon without anything there. And this one can be the beta, or this one can be so here, as we can see, there are 4 cis groups, and all these 4 we can acetylate them with acetone, give you that, and gives you that. Here we can either do these two or these two, because these are all cis. So you can do that, or you can do that. Which one is the majority? Well, first of all, we always know there is more pyranose than furanose in solution, so it's going to be one of these 2 rings. Do you have either the alpha or the beta forms that are more common? Among the alpha or the beta forms, which one is more common, normally in glucose, I'm not exactly sure. I think the alpha form is usually more common, if I'm not mistaken, but I can't remember exactly. This is the beta form, so I would say this one would be the most common one in solution, but just check up on that. Is the beta one or the alpha one more common in ribose? Whichever one it's in glucose. So I think in glucose the beta form is more common than the alpha, and the rest of the alpha is more common than the beta, but just check up on this again. So I think this one would, the alpha form, is the most common one. Yeah, so that's basically how to answer. Just check it up on that, because I'm not exactly sure.